Okay, thank you, Marnik. Let me see if I can already share my screen. It seems so. So you should all be able to then log in. This is the website. I don't know, Marnik, if you want to put the link on the chat. Meanwhile, just in case somebody is not in here yet, you
Yes,
just
sounds
need
good.
to sign in. And then if you already have created the account yesterday, this will take only a few seconds, or if not, it may take a couple of minutes. But while we wait for that, you can also maybe paste the address, the link for the tutorial material. And so you can see everything is here. So in order not to repeat much what you will already be reading from the instructions and what Marnik has said, I just want to maybe make a few clarifications on the key points that you're going to find in this tutorial. So as Marnik already gave you an overview of what you will be doing here, the first thing that you're going to start with is well, with the objective of then eventually running quantum espresso calculation. You have already been running quantum espresso calculations the whole week, this whole 2 weeks now. So now you're going to learn how to do this through AiiDA so that everything will be automatically tracked. And in order to do so, you first need to populate the database with the information you want to use. And so the first thing would be interacting with this database. Here is this funny drawing just to illustrate a bit what I'm talking about. The first step is then how to interact with the database, because you won't be directly seeing the database. You will be interacting in a user interface that will be how you've been working this whole 2 weeks, like with the terminal. And so you will have to learn to send information to the database, to create data nodes that you will want to use in your calculations. And then also not just create the nodes, but use them. And to use them, you need to reference them somehow. And in order to do this, you will be using a property of each of the nodes. Each node that you create on the database, each node that exists on the database, can be identified by one of two possible identifiers. One of these identifiers is the unique identifier UUID, and the other one of these identifiers is the PK or ID, solely ID. PK or ID are interchangeable for us. And what is the difference between these two identifiers? It is explained in the tutorial, and I may actually quiz you on that afterwards, so pay attention to that. But in principle, these are the two things. So if you want to say, oh, I created this node, when you create a node, AiiDA will tell you, okay, this is the identifier for that node. So then if you want to do something with this node, even like show me the information of this node, all you need to do is use this identifier. So Verdi node show and this number. So you will be learning how to use this throughout the tutorial. Pay attention to which is the identifier of each node. And if you want to reference a node, to see which is the proper identifier of that node you want to reference. So that is one thing to pay attention to. Then, as Marnik said, you will run this calculation. And then once you know how to do this, you know how to do what, run a single step, a single calculation, we will illustrate how you can leverage the power of AiiDA to then automatically run full workflows. And we will do this by just providing you with one of these workflows, and so you can see how easy it is to set everything that you need and to run it and automatically get the result of a complex process, what would otherwise be a complex process and series of different steps that will perform automatically. Of course, you can check, there are ways you can check what's happening behind the curtains, you can see what this workflow does, but we will not get into the details of how to make this by yourself. You will probably get some ideas because you will see that we will be doing a lot of Python scripting. So if you catch easily into that, you can start getting some ideas of how to concatenate different calculations into one of these workflows. But of course, to have the full advantage of the specific tools we have for this, you need more specific knowledge. For this, you have well, you can check the AiiDA documentation. Also, Marnik, maybe link in the chat if you may, which has a lot of information on AiiDA, which also includes like a getting started guide with instructions of how to install it in your own workstation. This was one of the questions that we had previously about like the space or how much it would cost to have a. And no, this is completely free. You can install it in your workstation and work from there, and everything is stored locally. And we also have tutorials and different how-to guides, which include making these workflows. But also, if you want a more personalized, dedicated thing for this, we will also have soon in July a tutorial dedicated to AiiDA, 1 week tutorial, which you can see. We will talk maybe more about this later, or you can ask us if you're interested. But you have all the information again in the AiiDA.net website. So the last thing I wanted to tell you about this is that you will be doing all of this that I already described. Start interacting with the database, creating nodes, referencing nodes, running the calculation, running the workflow, and then we're going to use a tool in the Materials Cloud that allows you to, gives you another way of exploring your database. We will finally, in the end, see another final way of exploring database with Flaviano. But before that, we will be doing some exploring using the Materials Cloud here. And it requires you to do to start the REST API service in AiiDA. So the way you do this, I want to show it to you now. I will show it to you again before the break, that it will be closer to when most of you will be doing this part. But for those of you who are quick, I want to just show you what you have to do. So you have to open, we'll open one terminal. And after you have worked and familiarized yourself with AiiDA, you needed to, and you want to explore it through the Materials Cloud, you need to somehow connect these two things. Connect what this service here where you have been working and the Materials side, the Materials Cloud website. So this is done through 2 steps. First steps is just start the REST API, and it's as simple as running BERCX REST API, which is the command here. You just start this, and then starts running in your terminal. You won't be able to keep using this terminal, but this already will be exposing your database. But since we are inside this Jupyter Hub virtual machine, we have to do a second step of exposing the database, which is the ngrok setting, which is here. Again, this is just so you have like a visual idea of what you will have to do, but the instructions are all already on the tutorial page. Just want to show you what it looks like, and so that it blocks the terminal so this doesn't surprise you. Again, I will run the ngrok command. Again, it blocks the terminal, but it's exposing my database. Now, externally, this is ready. And finally, you will have to go to the Materials Cloud website. This link will show you directly into the Explore section. And here you have the Connect Your REST API. Typically, if you were working directly in your computer, you would use an address like the one that appears here. But since we're having to go through ngrok, what you have to do is copy this address that is here, where it says forwarding, and it says this localhost 500, the address that is previous to that one. You need to copy this one. And then, and this is at the end, you have to add API v4, I think. And then you will be able to connect to your database and explore it through this interface. So again, just to show you what the process is like, because there are not many images of this in the instructions, so that you have a visual idea of how to do this and how to what needs to be copied where. Again, I will try to do this again before the break, so that you get these instructions again closer to where you need. So I think that's it for me. I will leave you, well, if somebody has any questions, we can look at them now. You can ask them now, or else you can start with the tutorial and start learning through practice.
Yeah, just for people who are a bit confused, Francisco's already just explaining how to connect to the REST API, because this process is a bit more complicated on these Jupyter Hub clusters. But you should just start at the beginning of the Quantum Espresso section of the material. So just start there, executing the commands that are shown there. And then this, maybe we can still repeat this later on if people are having issues with connecting to the REST API.
Yes. Again, I just maybe to have like a spatial idea, I just show you the very first part of the tutorial, what you will need to know about PKs and UUIDs, and pay attention to this. And the very last part of the Quantum Espresso section, where you will see, you will need to do this connection that can be tricky. So, but the instructions are there. This is just for you to get an image of what it looks like. You will be able to follow it through the instructions now more easily.
You can import the structure. You can and then look at how to import the structure into your database, and just follow the commands that are executed here. And let us know if you have any questions, right? Next, you'll move on to running a calculation, where first you will set up the code that you want to run, which is just BW code from Quantum Espresso. And so simply follow these commands. Some people also were wondering how to copy these commands into their terminal. Here you can use this nice little copy button feature. So you simply click on that, it says copied, then you can go to the terminal, and then, well, I think you can also just do paste by clicking right click and clicking on paste, but typically you will have a shortcut for this depending on the operating system you have. For example, in my case, it's Mac, so I do Command V. In case you're running Windows, it's usually Control-V. And so then you can simply do that, and then you can execute the command. At this point, I don't have any codes in my database, of course. This is still empty. But if you set the code, it will show you the code that you have set up. Okay.
Marnik, maybe you want to show them again where to find the link to the cloud computer system that they can run this. If maybe somebody lost in the Slack the information.
I put the link again in the Slack recently, so it should still be there. I can copy it again if you like. It's just in the final part of the Slack, so you can find the link to the Jupyter Hub cluster and also the link to the material.
That should be fine. Yeah.
So I think it should be okay. If anyone has any problems, again, just either raise your hand here so we can help you out, or let us know on the Slack or Zoom chat. So it's a question from Amal on how to specify the PK. Well, you simply, if you want to, for example, do show growth, for example, in the node you just imported, you can just specify it as the number of the PK. If your database is entirely clean, this PK will just be 1. So you can specify it as a number for the command line interface for Verdi.
There are other questions in the chat here on Zoom. When doing output, where are the files saved? Which folder?
So if you've already run the calculation, and AiiDA will have taken the output files that it retrieves from the calculation, and it will put them in the repository. So there's 2 places where information is stored in AiiDA. You have the database and the repository. The database is usually for smaller information, such as specific outputs, Fermi energy, and so forth. And then the repository is for larger outputs, either larger matrices, which are stored as NumPy binary files, or, for example, the output files are also stored in the repository. Node repository is also, well, in this case, it's online because, of course, you're running on this Jupyter Hub cluster. But if you would have installed it on your workstation, when setting up your profile, you will specify where this repository is. So you can do this, for example, on an extra a hard drive that's attached to your workstation. And so you can store these typically larger files in the repository. Something like Git. No, I don't think you can compare it to Git. It's basically just a file repository. So basically a collection of files on your workstation. And if you do output ls, you will simply see for a specific calculation which files are stored as output files in the repository on your workstation, right? And then you can see with the output cat, you can then, for example, get the outputs. And if you want to store it in a different file, you can, of course, redirect this in Linux to the specific file using typical Linux syntax or bash syntax. I also see a question on AiiDA sudo. So if you do AiiDA sudo install ssp and then /h so to get the help, you will see how to also specify different protocols for these pseudo potentials. So I think the command for the protocol is -p. There's also -v, the option for the version and so forth. So you can install all of these pseudo potential families for the SSP quite easily using AiiDA sudo install commands. We also have support for pseudo dojo pseudo potentials. So those are also supported with automate installer commands. If you want to install your own pseudo potential family, you can also do so, but for this you have to consult AiiDA pseudo documentation. This is a bit more involved. So to answer Christian's question, for the PK, you actually have to fill in the PK of the node in your database. For example, for the structure, after you've imported it, it will tell you what the PK is of the structured node that is in your database. And so you have to fill in this number actually when doing the Verdi node show command. Same result is shown on screen. I'm not sure. Okay, yeah, this was also answering that. I'm not sure what Bindia means with his or her question. To answer Amal's question, you have to put in the PK, the primary key of your code. So if you set up your code, you can now do Verdi code lists and see which is the PK of the node you have set up. So then you find that PK, you plug it into load code, and then it should be working for you. Yes, exactly, Amal. If your PK of your code is 2, then you simply plug in code 2 for this code PK. So to answer Alberto's question, if you've already started a daemon previously, which you should have done when running the calculation, the daemon will still be running. So the daemon, you can always check the status of the daemon by doing Verdi daemon status, as I write in the chat now. So you can always execute a command to see if your daemon is running. If it's not running, you can always restart it with Verdi daemon start. And if for whatever reason you want to stop it, you can do so with Verdi daemon stop. So to answer Amal's question, you won't get any output because you load the code and then plug it into the code Python variable. So it's normal if you don't get any output there, but it will still be stored, of course, as code inside the code variable. For Ignacio's question, well, the Verdi command is in the bash terminal. So if you're running Verdi shell, you're inside the IPython terminal. So there you cannot be running any Verdi commands. This is only when you're running bash. You can clearly see the difference between commands that have to be executed just in bash with this $sign, and also the code snippet will have a blue background. And then the commands you have to execute in the Verdi shell will have this in and out for the prompts of the IPython shell. And then you'll also see that the background of these code snippets will be more yellowish. Actually, Francisco just made a very good point in the chat. So you can also, if you're inside your Verdi shell, execute bash commands by simply adding an exclamation point. So in your case, let me, yeah, exactly. So okay, copy this. So you can do this inside the Verdi shell as well, in order to then quickly see again, well, what the PK of your structure is in case you've forgotten it. Alternatively, of course, you can open a second terminal as well, and in one you can use a Verdi shell, and in the other you can then execute bash commands, whatever workflow works best for you. Thanks, Tim. That's nice to hear. So for the structure PK, you can execute this command, Verdi data structure list. Oh, crap. I now notice that I apparently only sent this to Francisco because he sent me a message. But this is the command that you can do inside the Verdi shell to figure out again what the PK is of that structure in your database. Syntax error. I'll have to see. Ivan, we do have breakout rooms available in case you want to help people one-on-one, right?
Sure, sure. It's I don't know where you should maybe. Okay, let me check. Massimo. Massimo. Yes, we usually. Yes, do we have breakout rooms? I don't see them.
Oh, sorry. There was someone close them. Be careful, please, because all of you have the right to close them. All the
Okay,
co-hosts, someone has closed. They were open. Okay.
Okay, now I can see them. Do you see them?
I see that Amelia's problem has already been solved. That's great.
Okay.
So the breakout room is no longer necessary, but thank you, Massimo. Hopefully, I'll probably need them later again. So, so to answer Amal's question, so the PKs, again, these are primary keys, which are identifiers in your database. So as is also mentioned in the tutorial material, it will depend on what's already in your database when you are setting up the structure. So to figure out the PK that you need to put there, you have to run this command, Verdi data structure list. I'll post it again. You can do this in the Verdi shell. So if in the IPython kernel, and there you will then get a list of the structures, which should be only one, the silicon structure you just imported, and it will show you the PK of your structure in the database. And then you can plug that in the structure PK.
To Florina, no, remember that, so using the exclamation mark before the Verdi works when you are inside the Verdi shell, but if you're also the Python shell, but if you are in the Bash shell, which I think you are, you just, you don't use the exclamation mark.
So Daniel, to get the code PK, you normally should have already set up your codes with the Verdi code setup command. And if you've done so, you can then again execute Verdi code list to figure out the PK of your code in the database. If you're doing this again in the Bash, you can just do Verdi commands, Verdi code list. If you are doing this inside the Verdi shell, you first have to add this exclamation point. Okay, well, maybe Francisco, you can move into the your tutor room and help Alberto.
Yeah, I'll be there.
To answer Joseph's question, so the builder indicates that if you try to run the builder through the AiiDA engine, it doesn't have the required value for structure. So at some point earlier, you provide the structure to the builder. And so it seems that this step has not been executed. So to answer Emil's question, the data factory, I mean, when you're doing the initial calculation, you actually specify the k-point mesh, if I'm not mistaken. So there, it will not automatically determine what the appropriate k-point mesh is. When it comes to the workflow that's ready to run with the protocol, well, we've done a series of tests with different k-point densities. And so we found that for a certain k-point density, you have a reasonable position for a law structure. So if you're using this default protocol, it will simply determine the k-point mesh based on that k-points density value, which basically specified by a distance of 0.15 inverse angstroms between the k-points in reciprocal space. So to answer Florina's question, when you're doing Verdi node show, you have to plug in the PK number of one of these structures. So I see you've already imported silicon twice. So now you have two nodes in your database, the PK 1 and 2, that represent straight silicon structure. So you can then just do Verdi node show 1 or Verdi node show 2, and then you will get more information on that structured data node from your database. So maybe for our last question, well, so you have to make sure that the structure that you're providing, of course, is actually the structured data. So if you've loaded the node into the structure, you need to make sure that this PK actually corresponds to the PK of the structured data. So if you, for example, just now in the Verdi shell do structure, does it show you that this actually corresponds to a structured data or not? So to answer Amal, it basically, you have to figure out what the process ID is, or the process PK is, you first should run 30 and then you can see the list of processes, and you should get the right PK. So I'm assuming that the node in your database with PK2 doesn't correspond to the actual process node. This will most likely be either the structure or the code. So we are running close to the break, the coffee break. I just would like to say one thing before you can all have a rest and then continue with the tutorial afterwards. For the second part of the tutorial, I'll put the link in the Zoom chat. We have to import a database from an online repository. And so if you follow this link here, let me quickly share my screen. You will wind up on the second part, or the second section of the tutorial hands-on. And so here's a command that actually imports this database. Now we've noticed that on these Jupyter Hub cluster, it can take quite a bit of time for this import command to complete. So maybe while we have our coffee break, it would be good if you can basically copy this command, then go to your terminal, paste it there, and then start importing this database already. So once you're completed with the first part of the tutorial, you immediately already have this data available in your database. So now it's technically time for the coffee break. Of course, if you want to keep on working on the material, feel free to go ahead. I'll just be here to answer questions still, or move into a Zoom room if there's anyone with problems. Now we're seeing our question from Gosde. So again, probably the node you have loaded into the structure variable in Python doesn't correspond to a structured data node. So you should check again if you just do in the set of result structure. Does it show you that this actual node that you have loaded is a structured data node or not? Maybe I can also move into a breakout room with you to help you out. And Amal, to open the PDF file, maybe quickly share my screen again. So you can go to the file manager, right? So if you just click on this in the main tab of the Jupyter Hub terminal, you can just click on the file manager, and then you can navigate to the file that you want to open. Typically, you can just click on the file and it will open in a different tab of the browser. But if there is an issue, you can always also just click on the file and then click download and then open it on your machine. Yeah, to answer Fernanda's question, yes, you can open as many terminals as you'd like. This may indeed be handy if you're doing, for example, one terminal for the bash shell and one terminal for the Vert shell. monitoring the Slack channel quite closely today and tomorrow. So we'll be happy to answer any questions you have there. Yes, so if you to answer a mouse question, so the PK you have to load here is the PK of the output parameters dictionary, right? Because this actually contains the energy of your system. So to see what the output parameters dictionary node PK is, you can do Verdi process show. I think if you've been just following the tutorial, the PK should be 90. If not, you have to, of course, see with Verdi process list which are the PKs that are available. And then if you do Verdi process show, it'll show you in the output nodes which one is the actual output parameters node. And so you need to plug in that PK in the load node command that you showed. Maybe I can quickly go in the breakout room with you, Amal. I think, yeah, they should still be open. Okay, there's no tutor room with my name on it, but we can just move into the tutor room, and then I can have a quick look. Okay, Amal. Hi, Amal. So it will indeed stay like that because now basically the Verdi REST API is running. But in order to get this to work, maybe I can quickly help you out again in a breakout room. So let's move back into the breakout room and then I can help you set this up. All right, so hopefully most people have come back from the coffee break if they have taken one. Since some people have already indicated on the Slack and also in the Zoom chat here that they had a bit of issues in setting up the ngrok and everything to use the REST API and explore their database, I just want to quickly show this again, because I think at this point, most people or a lot of people are already at this stage in the tutorial. So I will simply quickly share my screen and go over these commands so everyone can understand better how to actually execute this. So this is in 1.6, 1.5 of the first part of the tutorial. And first, as it says here, you have to start the REST API. So the REST API simply serves the data in your database, so other instances can do get commands, so you can get information from your database once this REST API is active. Second, because we're working on a remote resource, so we're using this Jupyter Hub cluster on Amazon Web Services, we have to somehow expose this local URL to a public one. And so in order to do this, we have used this tool called ngrok. And so when this REST API is running, you simply open a second terminal. Again, you can just do this by going to the main Jupyter Hub page and clicking on terminal. And so while your REST API is running, you'll also then open this ngrok, which will basically connect your local host where the REST API is serving the data to this public URL here. And so this public URL needs to be provided, of course, to the Materials Cloud Explore section, because this is actually the interface by which you can then explore your database. So then in turn here, there's a link to the Materials Cloud Explore section. So you simply click on that. You plug in this link, but you still have to add, and this is important, /API/version 4, v4. And if you do that, then you'll be able to connect to your database. And then this looks something a little, let's do like this, there we go, like this. And then on the left, you can look for processes. I haven't run that much here, so there isn't that much data available. But so then you can start exploring your provenance of your database. So what's actually happening here is that, and you can also see this if you look at REST API here. So as I am going to explore certain parts of this database and I click on it, this Materials Clouds Explore section API simply asks for information from your database, which is now exposed via ngrok, right? So the database never leaves your system. It's just still on the remote server that you're using now, but it simply, the Materials Cloud simply retrieves this data via get commands and then can show it to you in this Materials Cloud Explore section. And then if you have a certain calculation, you can look at inputs of your calculation files, you can look at the output files, etc. Okay. So hopefully for everyone who's reached this point of the tutorial, you've now been able to set this up. If not, again, ask questions. We can either just answer in the Slack or go into a breakout room so we can go through the steps in case you have difficulties in setting this up. So yeah, I mean, starting with the second part, well, you can already start. Maybe Flaviano can already give a brief overview of what you'll be doing in the second section of the tutorial. So if you've completed the first one, great, then you can already get started there. If not, no worries, of course, you can still continue on the first part of the tutorial and then continue later. So maybe Flaviano, I can give you the word and you can give a little overview of what they were doing in the parts on managing your data and querying. I'm not sure if you're already talking, Flaviano, but you're still muted.
Thank you, Marnik. So I was saying that what we have learned in the first part of the hands-on was we learned how to import the structures, for example, to the AiiDA databases, how to set up the codes, how to set up the calculation and running it. And then we did some analysis of our results and so on. Furthermore, we learned how to run calculations through workflows that takes a very complex calculation and simplify and automatize the process. And now imagine that we have done this thousands and thousands of times. And all this bit of information, I stored as nodes in the AiiDA database. So structures, code, everything are nodes, and everything is in the same box. We have a flat organization of those nodes. So what we want to do in the second part of the hands-on is to create some organization, maybe to group together some nodes, maybe because they share some common features and properties together. So we want to organize this data, creating groups. And also we want to search for data. You might want to query to find specific groups. Let's say we want to find all structures that are a result of a relaxation calculation. Not in structure that you input, but the one that are a result from calculations. So these also you're going to learn a little bit in the second part of the tutorial. So I will let you to it. Please go to the second chapter of the hands-on and go reading slowly, bit by bit. It's important that we pay attention to every bit of information because there are new concepts that you need some time to absorb. And also, yeah, let us know when you have any questions. So please do it slowly. For those that have already finished the first part, those that are still working on it, don't worry, please continue working the session 1. And then when you are done, you can start session number 2. And we'll be here to help you with any question.
And speaking of doing things slowly, this first import command, as I've already mentioned before, can take a bit of time. So if you haven't done it already during the coffee break, then maybe just start it now and then have a little extra coffee break or read to some other section of material already, because it can take a few minutes. It's mainly because this is all run on this Jupyter Hub cluster on Amazon Web Services, and it seems that somehow this could take quite a bit of time there. So so give it a go and let us know.
What Marnik means is exactly this command over here. The first command of chapter 2, please do it as soon as possible. It takes some time. It takes about 10 minutes or so.
All right, so there's about 45 minutes left for the hands-on, but it seems that many people have already finished all the material, which is good to hear. I was worried that we might not have enough time to finish everything. But before everyone's done and already leaves the Zoom meeting, I would like to still share, wait, there you go. Some details on how you can still connect with us after the tutorial. Of course, if you're still working on the tutorial material, we'll still be online until 12:30 in the Zoom meeting. And in the afternoon, if you still have questions, don't hesitate to ask on the Slack channel. If you are still working on material later, just a quick reminder that the Jupyter Hub clusters will be shut down tomorrow at noon Central Eastern European time, summer time, CEST. So make sure that you remove any data that you're interested in before then. And then afterwards, you can always stay in touch via the AiiDA mailing list, or if you have certain issues that you'd like to raise, you can always go to the GitHub issue page. I have to update this link here. And of course, this is only a small introduction to AiiDA and some of its features. In the summer, from July 5th until 9th, we're organizing a longer tutorial for AiiDA. So if you're interested in learning more, you can register there. I'll put all of these links in the Slack channel so you can find them easily. So other than that, you can also still continue working on this. Wait, I have to share the right screen here. On this extra appendix section that we have here. This is basically a more basic version of the tutorial, which without talking about anything related to quantum espresso tries to explain constants as provenance and everything, and the different types of nodes in more detail. So you can still work through that if you're interested. So with that, I would like to already thank everyone for joining. If you have any more questions, of course, don't hesitate to ask in the Zoom chat, raise a hand, or contact us in the Slack channel. As I've already said previously, you can always still contact us this afternoon or whatever the time may be in the time zone you're in, and we'll be happy to still answer questions.
Thank you very much, Marnik. Yes, I don't see questions on the YouTube stream here, but I see that I think you answered already all the questions on Slack and Zoom.
Yeah, I think most of these were related to the tutorial material, so we've answered there. So
yeah.
And again, I mean, we'll still be here. The tutorial isn't over. I just already, because I saw people were leaving because they were finished with material, I always want to make a few notes. But I mean, we'll be here for at least another 45 minutes to help you out. Also in Zoom breakout rooms if you want. And again, continue working the material. You still have time until tomorrow, and the Slack will still be open even afterwards, as long as I'll be monitoring this Slack channel. I'm part of I have it part of my Zoom Slack workspace. So ask questions there. We'd be happy to answer. Yes, keep on working on the tutorial at your own pace.
Okay. Do you want us to put the screensaver here, or you want to stay connected? Just let us know.
Yeah, like I said, I'll stay connected until, of course, 12:30, until the hands-on is finished. I just want to already make some notes because people were starting to leave. So. Okay,
so we leave the Zoom like as is now, and yes. If someone wants to ask, even in Slack or here in chat or raise hand, of course you are available for answering, right?
Yes, of course.
Okay. So thank you very much, Marnik. Thank you.
You're welcome. Thanks for the invitation.
And also to all the tutors, of course.
Yeah. Marnik, do you want to mention the main AiiDA tutorial that are going to happen in July?
So I thought I did, but maybe it was very quick. But I'll put all of this information again in the Slack channel, so it's also at the end. So if you're at the end of the tutorial, what's next? There's a link straight to the registration form. So people should be able to find quite easily. This will be a 5-day tutorial where we explain more because, of course, there's quite a bit more to learn from AiiDA that we can not all fit into one morning. So definitely encourage everyone, all these quantum ESPRESSO experts now, to join for this larger tutorial as well.
I saw, yes, here there's a question. Yes, we will come back at 2:30 chess time for the special guest lecture from Nicola Spalding. So yes, in case that is the next appointment. And I see that maybe Tone raised the hand. Maybe I don't know if
no.
Oh.
I just made a reaction of applause.
Okay.
Yeah.
Thank you. Yeah, so this kind of confusing indeed.
Yes. Yeah, because yesterday we used the raised hand option to have feedback. So when they finished the exercises, we asked them to raise hand to let us know at which points they were. So maybe this created a bit confusion.
To answer Christian's question, if you have run the command that actually creates this PDF, you can then go to a file manager. So on the main Jupyter Hub page, you can open a file manager, and there you can then navigate to where this demo query PDF file is and simply open it there. I have noticed that sometimes if you try to open it directly, it doesn't work. It doesn't allow you to interact with it. In that case, you can just select it on the left and then click on download a bit above that. So then you can just start download it to your workstation and that way open the file. Let me know if this works for you. And to expand a bit on Afonso's question, so if you delete a node from a database, AiiDA will automatically delete certain nodes depending on the connections of these nodes in the database. Basically, for example, if you delete a certain calculation, it will probably, or for example, also delete certain outputs that are used in this calculation, right? So be careful with deleting nodes, because you won't just be deleting that single node, you'll also be deleting other connections throughout the database to make sure that this database stays consistent. I can actually maybe forward you to the documentation that explains how this exactly works. Just a second.
Yes, I'm about to copy the link if you.
Great, thanks, Francisco. So, and you can also change the rules of how AiiDA does this, right? Provenance consistency, exactly. So there you can see nice little charts that explain better how AiiDA actually deletes nodes from the database. All right, we're getting close to 12:30, the official end of this hands-on session. For those that are still working, of course, again, if you still have any questions after we end the Zoom meeting, don't hesitate to ask on the Slack. We'll still be monitoring this until this weekend for sure. And of course, I would be remiss in forgetting to mention that at 2:30, there is still a special guest lecture. So of course, everyone still attend that. And maybe Ivan still has some final words you would like to say now.
Yeah, I was just about to remember all of them about the special lecture. So yes, yeah,
Okay.
that was yeah.
Yes.
Yes, at 2:30 we have Nicola Spalding, and so we meet again here on Zoom. I think that Massimo can now, when we close now, we can put the screensaver, and of course the Slack channel is available for questions as usual. So
Exactly.
thank you very much again, Marnik, and all tutors for this AiiDA hands-on and lecture.
So thanks again for the invitation. We hope everyone was able to learn quite a lot. And of course, we thank also all the participants for their participation to this group.
Thank you.
Ciao.
Ciao, thank you.